Hey guys, welcome back, Mr. Mitchell here. In this video we're going to go over two worked examples to show you how to do problems involving reference frames and relative velocity. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says that a man is walking his dog at a speed of 2 meters per second. A bus passes him at a speed of 12 meters per second in the same direction. An old woman waiting at the bus stop is standing still and watching everything. Part A says, from the man's frame of reference, what is the speed of the bus? Well, the first thing we need to realise is that the man is already moving at 2 meters per second. So the bus must be moving at 12 minus 2 equals 10 meters per second with respect to him, since they are travelling in the same direction. So this is the case where the two observers are moving in the same direction, so in order to get the relative velocity we need to subtract them, so we end up with 10 meters per second. Part B says, from the woman's frame of reference, what is the speed of the bus? Well, remember we're told in the question that the woman is standing still, so she is a stationary observer, so she will simply see the bus moving at the speed that it's doing from the question. So since the woman is at rest, a stationary observer, she sees the bus moving at 12 meters per second. Part C says that a passenger on board the bus sees a runner zoom past in the opposite direction at 4 meters per second. What speed does the passenger see the runner moving from their frame of reference? Well, remember the passenger is on the bus, and we've seen that with respect to a stationary observer, the passenger will be moving at 12 meters per second because the bus itself is moving at 12 meters per second with respect to a stationary observer. And we know from the question that the runner is moving at 4 meters per second in the opposite direction, so relative to them, the passenger is moving at 12 plus 4, which equals 16 meters per second. So this is the case where we've got two observers moving in opposite directions, so we need to add the velocities. Question 2 says that Mr. Mitchell is driving his car along the motorway. The speedometer records a speed of 75 miles per hour. He overtakes Mr. McMahon's car, which is travelling at 55 miles per hour in the same direction. Part A says, what speed does Mr. McMahon see Mr. Mitchell moving at? Well, in this case, the observers are moving in the same direction, so we can subtract the velocities. So we get 75 minus 55, which gives us 28 miles per hour. Part B says that further along the road, Mr. DeMellis is travelling in the opposite direction at 65 miles per hour. What speed does Mr. DeMellis appear to be moving at according to Mr. Mitchell and Mr. McMahon? Well, for Mr. Mitchell, first of all, the observers are moving in the opposite direction, so we can add the velocities this time. So we take the speed of Mr. Mitchell, which is 75, and add it to the 65, which gives us 140 miles per hour. And for Mr. McMahon in part 2, the observers again are moving in the opposite direction, so we add the velocities for them, but remember Mr. McMahon was moving at 55 miles per hour, so we get 55 plus 65, which gives us 120 miles per hour. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe, and I'll see you in the next one. Take care.